And welcome back. It is the 17th of April, higher plus 5 a day. And let's just go straight to the first one. Okay, now this one's not too bad. So again, it's a skill that we need to know. We need to practice it a few times, but it's easy mark in the exam because you'll know what to do. I'm going to factorise this first of all. So I would clearly notice that 2x is going to be 2x and x. I'd also notice that this is a minus and this is a plus, which means both of these are going to be a negative. And then 3 is going to be 3 and 1. So the question is, do I put the 3 here or do I put the 3 here? Because I want minus 7, I know minus 7 is 2 times 3, which is 6, minus another 1. So therefore I need to multiply the 2x by 3 and then take away another 1. However, remember, I'm still not done. This is a quadratic inequality. So the critical values are a half and 3, which means that if I do my quick sketch, so that's a half and that's 3. I want all values that are less than 0, which are the values here. So therefore my x is going to be between a half and 3. Question done. Next question. Shown below is the time taken to deliver 128 meals. Okay. Erin drew a histogram. Well done, Erin. The frequency density for the second group is 5 times larger than for the third group. Okay. Find y. Right. Okay. This is a really good example of, I don't know how to do this straight off, but basically just doing what you know how to do, which is in the right vicinity of what you're doing, and then not hoping, but sort of presuming it will fall out. So what do I have? Well, histogram. So I've got class width, I've got frequency, and I've got frequency density. The class width, I don't really need A, but I'll do A anyway. So class width of A is 20, of B is Y minus 30, and of C is 120 minus Y. The frequency, it tells me, is 90, 25, and 13, which means, now we're finally getting to I. So frequency density is the area, which is 25, I'm not doing that one, is 25 divided by Y minus 30. And the frequency density of this one is 13 divided by 120 minus Y. And then what does the question tell me? The question tells me the frequency density for the second group was 5 times larger than for the third group. So in other words, let's do it over here. 25 over Y minus 30 is equal to 13 over 120 minus Y. Now, if the frequency density of the second group was 5 times larger than the third group, I need to multiply this one by 5 in order to get the second one. Okay, now I've just got an equation. Now I need to solve an equation. I'm going to do some cancelling first. So I'm going to cancel this down by 5. So that's going to give me 5 and that will go away. Just makes it a little bit neater. Then I'm going to cross multiply both sides. So 5 times 120 minus Y is equal to 13 times Y minus 30. Now in a non-calculator exam, just do this very carefully. In a calculator exam, get your calculator out just to make sure you don't make a silly error. 5 times 120 is going to give me 600 minus 5Y is equal to 13Y minus, well, 3 times 13 is 39 plus a 0 is 390. Then I'm going to add 5Y to both sides, which gives me 18Y. And I'm going to add 390 to both sides, which gives me 990, which tells me that Y, and I'm going to hope this gives me a nice number, so 990 divided by 18 is indeed 55. So my answer to that, after a bit of working out, is 55. Good question. Next question. 2 customers are chosen at random. Find the probability they are both receiving their meals in under 30 minutes. So under 30 minutes means I just care about these customers here. So the first customer is going to be 90 divided by, well, how many are there? So the 128 meals. Talks about that in the question. So it's 90 over 128. The second customer, there's 89 to choose from and only 127 left. Calculator out. So that is 4005 over 8128, or approximately 0.493 as a decimal, which of course is 49.3%. And that's it. Good question. Next question. Prove that the sum of squares of 3 consecutive positive integers is always 1 less than a multiple of 3. So let values be. So this is the setup stage. Always set up algebra conclusion. So prove the sum of the squares of 3 consecutive integers. So let values be n minus 1, n, and n plus 1. And then we do the algebra part. So we're going to do n minus 1 squared because we're summing And let's write it down, so n plus 1 squared. So we're summing the squares of 3 consecutive integers. Okay, let's work this out, which is equal to n squared minus 2n plus 1 plus n squared minus n squared plus n squared, sorry, plus n squared plus 2n plus 1, which is equal to, well, n squared plus n squared plus n squared is 3n squared, minus 2n plus 2n goes away, and then 1 plus 1 is 2. Right, what am I trying to show? Prove that the sum of the squares positive integers is always 1 less than a multiple of 3. Well, I've got, sorry, screen moving, sorry. I've got plus 2, which is 1 less than a multiple of 3, but I'd like this to be a bit neater. So I'm going to do something slightly different. I'm going to say this is the same as 3n squared plus 3n squared plus 3 minus 1, because 3 minus 1 is 2, which I can then say is 3n squared plus 1. That's a multiple of 3 minus 1. Now, in a GCSE exam, just state what you've done, just to be clear, rather than just go, well, here's some algebra. I'm not telling you what it is. So I'm just going to say, which is 1 less than a multiple of 3. So I've just stated the question in many ways, just to make sure I get that sort of conclusion mark at the end. Good question that, either way done. Next and final question today, I can see the word prove again. Prove the angles in the same segment. So in other words, if this is my segment here, then AD means that this angle here is equal to this angle here, are equal. Now this is always difficult because you're never quite sure what you're supposed to assume is true and what you can state. So there's this strange fact whereby you can use some circle theorems to prove other circle theorems because you're just allowed to state them as being true without saying why they're true. So I think it is perfectly okay to draw an extra line here where this is my center, and then just make the argument. So this here is angle A, let's call it, and this is angle B, and let's call this angle C. It just means I don't need to do the whole angle ABC terminology thing. And then I'm just going to say that it is true that A is equal to half C as angles at circumference equals half angle at center. And then I can also say that B is equal to half C, and they're both for the same reason. Therefore, A equals B as required. I don't really like that question. That question feels like it's just a bit uncertain as to what you can say is true and what you can't. But that would be the way that I would do it. Maybe you'd have to go a little bit further, but either way, you'd have to go through the center and create some radii. I was going to say good questions. I didn't like the end one, but good questions apart from the last one. That histogram question, probably the most challenging today. Either way, let me know how they went for you. Like, subscribe. See you tomorrow. Thanks all.